Hello everyone. In the last session, actually, we have discussed about different morphological characteristics that may be the drainage density, stream density, elongation ratio, compactness coefficient, all these things. In today's session, we will discuss about the factors affecting on the runoff. So there are the different factors which affects on the runoff. So we will start from the first one, that is precipitation characteristics. So, in case of precipitation, if the rainfall intensity is basically high, in that case, as you know, it has a connection with the infiltration. If the rainfall intensity is high and infiltration is less, so more runoff will be generated. So, and more peak we will observe at the outlet. Second is the shape and size of the catchment. So when I explain the second one with the shape and the size of the catchment, if I draw the both the catchments having a different shape, then I think we'll have the more clear idea. So I will. There are the two types of suppose catchment based on the shape. Suppose first we will draw. So suppose this is the any catchment. Here these are the small streams. Last time we also have studied the stream ordering as well. So these are the small streams. Now in this particular catchment, as water when rainfall occurs in this particular area, so it will be collected through the small streams and then it will become a part of this large stream and then finally comes to the outlet. So this is a fan shaped. Okay, basically the sides of the streams are almost same from a boundary, but and I will just mention the name here. This is a fan shaped. There's another one which is fern shape. So suppose the shape of this particular uh, watershed is like fern. So suppose this is the shape, and here there are the small streams. uh, this is the main stream, and these are the small stream. So now here in this case, if you see the streams, actually here from the boundary, whatever the streams are there, it may have the same size in case of fan shaped. And this one is fern shape. So I'll mention the name as well. Fern shape. So in case of this fern shape, actually these tributaries from this boundary up to the mainstream, it may have a different length. Here the length are quite similar for the different streams. So what happens if the rainfall occur in this area, so it will come because the size of the, we can say the length is same, so it will come at the same time, and that's why peak will get observed or the more runoff will be generated. Now in this case, actually size or length of this stream is different, so that the different time will be there when that particular water collected through the stream will approach at the outlet point, will be at a different time. So that's why actually here in this case more runoff we can observe. Whereas if we see the size even, and if we calculate per unit area, if the large area is there and if we calculate for the per unit area, so in case of large area, basically the runoff which is generated will be less per unit area. Actually I am talking per unit area, that's why it is less. Okay, basically because if the small area is there, then it will collected very fastly and it will come at the end. Then the next point is topography of the catchment. So basically this topography of the catchment is nothing but suppose slope, we can take an example of the slope. If that catchment has a large slope or high slope or it is steepy, in that case what happens, then runoff, whatever the runoff will be generated, will come fast at outlet with high speed, and more runoff will be there, because if it is more steepy, then less opportunity will be there for the infiltration, and that's why more runoff will be there. The next point is orientation of the watershed or the catchment. So what is mean by orientation? Suppose this particular catchment is there towards windward side, as we already have discussed in the precipitation chapter, the area which is at leeward side and the area which is at windward side. So which area receives more rainfall? Basically windward side. And if this catchment is towards windward side, then it will receive a more rainfall, and that's why more runoff will get generated. So this orientation also matters. Okay, orientation of the watershed or orientation of the catchment. The next point is about the geological characteristics of the basin. So geological characteristics of the basin is nothing but the type of the soil. Suppose there are the different types of the soil, like maybe sand, silt, clay, which has a different permeability. Okay, so we can connect with the example of soil. Suppose, so different soils have a different infiltration rate as well. Even if rocks are there in that particular area, then that if we observe the fissures through the rock, or we can cracks to the rock, so if the cracks are there, then water will lost through those cracks, and then runoff will not get generated. Whatever rainfall will occur, it will go through that cracks. If more permeable soil is there, more infiltration or the percolation will be there, so less runoff will be there. So in that way, basically this geological characteristics affects on the runoff generation. Then the next parameter is meteorological characteristics. So here it includes temperature or the humidity. Basically when the temperature is there, then what happens in a regular area, basically if the temperature is there, then more evaporation will be there. So if more evaporation will be there, so less runoff will be there. But it again vary with the location also. If there is an area which is covered with the snow, we can say, and then how it will affect, it will affect in a different way in this case. Because of the temperature, snow will melt, and at the same time if the rainfall occurs, then more runoff will be there. So it again depends on the location, these meteorological characteristics. The next term is character of the catchment surface. So basically when we mention the character of the catchment surface, it includes the land use land cover. So this character of the catchment surface is nothing but the land use land cover. So how this land use land cover affects on the runoff is basically I'll mention here. So there are the different types of the land use land cover. So we can say, suppose urban area is there, so then it may happen that there is agricultural land, there may be the forest, there may be the water. So everything, all these things will have a different runoff. So because if the land is covered with the agriculture or forest, so it will absorb more water, more infiltration will be there, and there will be the less runoff in this case. If the land is, suppose urban area is there, or the more settlements are there, it means that more pavement will be there, and the area will be covered with the concrete or impervious layer, we can say. Because of which what will happen, it will get a less opportunity to infiltrate, and it will affect on the runoff positively. Basically more runoff will be there in the urban area. Again water bodies are there, so basically what it will collect direct rainfall. Okay, so there won't be the any kind of infiltration in case of water bodies. So depending upon the land use land cover, or we can say the natural cover, actually it also affects on the runoff generation. So everything is interrelated. Basically when the agriculture land is there, it will have a connection with the infiltration. Then infiltration is more, less runoff will be there. So in this way basically it affects. Then the next characteristics or the next parameter which affects on the runoff is storage characteristics of the catchment. So if the catchment is so large, in that particular catchment, what happens if there are the small pits, or we can the small dams are there. Okay, so what happens when the rainfall will occur, runoff will get generated, but that water will be stored, okay, at artificial storage points. Okay, if more number of such small dams are there, or water conservation measures are there in this particular area, so whatever the runoff will be generated, it will be stored at a particular location, and that's why less runoff will come at outlet, and less runoff or discharge will be there at outlet. So in this way, basically, this storage characteristics of the catchment affects on the runoff generation. So these are the main characteristics, these are the main parameters, basically, which affects on the runoff generation. All these things are important. Why these things are important? Because it helps us to calculate the flood situation from a particular area. Because this flood, even most of the time we observe the floods in the cities only, because of not having a proper drainage facility, and the area actually which doesn't get an opportunity to infiltrate the water. And second is the rainfall intensity, even because nowadays, because of the climate change and all, we do observe that actually if you see, the quantity of the rainfall is not changed since many years. The quantity of the rainfall is near about the same, but the time is decreased. Suppose whatever the rainfall was generally, whatever the rainfall we had observed uh, for past years, that was for 4 5 months, from June to, suppose, June, July, August, September, like that. But many times now what happens, in less time actually, maybe 4 days or 5 days, more rainfall occurs, and that's why what happens, the land gets less opportunity to infiltrate, and that's why whatever the rainfall is occurred in a particular area will be converted into the runoff. And if there is no drainage facility, then again it will create the situations like flood. And that's why these factors are very important. And based on this, we get an idea that how much runoff can be generated. In connection with this, there is another term called as runoff coefficient as well. So what is mean by runoff coefficient? So if we mention the runoff coefficient as a k, suppose the value of k is nothing but the runoff divided by rainfall. So this is a runoff, suppose R, and rainfall is precipitation P. So whatever the, if runoff for the particular area, if we observe, that is 500 mm, suppose, and rainfall of that particular area is 700. So 500 divided by 700, whatever the quantity we get, okay, so that is nothing but the runoff coefficient. Okay, so why this runoff coefficient is important? Because it gives us an idea for the particular area. If the rainfall occurs is suppose 100 mm, so we can calculate that how much runoff can be generated. So like here we can convert, so this runoff is equal to k into p. So if rainfall occurs say 100 mm, then we get idea that this much amount of runoff can be generated, not exactly but near about same. So this much, that's why this runoff coefficient factor is very important. Actually, this runoff coefficient factor is basically depend upon land use, land cover, and what kind of soil is there. So there are the different types of the soil, as I mentioned, that sand, silt, clay. So depending upon the infiltration rate of those soil and natural cover, so there are the different values for the runoff coefficient. Suppose if the commercial industrial area is there or urban area is there, then value may be near about zero point 0.9. If the forest area is there, then it has 0.05 to zero point 0.2. If concrete pavement is there, then it has a 0.85. So like that, there are the values. So these are the standard values also, so from which we can calculate the runoff, or we get the idea that this much amount of runoff can be generated. So we will also solve few problems on the basis of this concept. So we will stop here. Next session we will discuss about the phi index and weight index. Thank you.